today we're just going to talk the basics of electric fencing, just how it works. It's a lot more technical product than you know, wire rigid fencing. So we just need to know a few terms and what they mean, and basically what the electricity is doing and where it's flowing, and then it'll become clear to you when I start talking about earthing systems and lead outs and stuff like that, why it's important to have your electric fence system running at its optimum. Why do we use electric fencing? It's very effective at keeping livestock in and away from fences because it is a psychological barrier. So it's a very strong psychological barrier, and you know yourself if you don't want to touch the fence, do you? It's in your head, don't touch the fence, you know, or I don't want to get too close to the fence, or I've got to go and turn it off to repair that. And sometimes you go, oh, look, I'll just fix it, and then you get a belt and you go, oh, I wish I had gone and turned it off. So it's the same for wildlife, any mammals, wildlife and livestock. It's very strong. So it's super important to have an effective fence so you get that psychological thoughts going in the animal. If they're thinking, oh, that's only a tickle, you're never going to hold them back, because especially things like, where's our reel? Especially things like this, there's nothing physical at all with that, nothing at all. So the only thing holding that animal in that area is its thoughts, is psychological. If I go too close to that, that's going to hurt. So yeah, so super important to have your fence working well, because if it's not, we haven't got that psychological barrier. All right, how it works. So who knows what sort of system we use? Who knows what sort of power supply we use that comes out of the unit, not into the unit, out of the unit? Does anybody know what sort of power supply we use? DC. There's your pegs. So direct current, we use a DC system. So it's safe, but it's just exactly the same as your car. So if the earth terminal, or you've got a dirty where it joins onto the frame on the car, if that's dirty and not a good connection, you turn the key, you don't get that circuit, and the car won't start. So it's exactly the same with an electric fence. It comes out along the fence, the animal touches it, it goes through his body into the ground, and the important point here, it travels back through the moisture in the ground. So what makes soil conductive is moisture. So it goes back through the moisture in the ground to the earth stakes and back to the unit. Now, only what gets back to that earth terminal is the shock that that animal gets. So if only half travels back because something's not working well, he only gets half a shock. If 10% is getting back, he only gets 10% of the shock. And the thing is that you can put a fence tester on there and it can be showing 8,000 volts or 8 kilovolts, but he is not getting that full shock. So we will go into it in great length about all these components and how we make sure we get it right, and alternatives to using the ground. So we'll go through all that. We can build a permanent fence. We can, it can be a boundary, an internal. So we can use electricity in a permanent system. We can use it to protect your investment. You've spent $1 zillion on ring lock and posts, and the cattle or the sheep are still rubbing on it. So electricity to keep them off of that. We can use it in a portable system. So, you know, in a temporary system we can shift, and it's easy to control. So we can use power off existing fences to power that. We can put a solar unit in there, so to power it. So we can have various options, but yeah, so it's very handy stuff. But like I say, we need that working well, don't we? Because there's absolutely nothing physical about that fence. All right, so these are the bits and pieces, that the four main building blocks to a fence. So with the energiser, the power supply, lead out will go into that. Lead out is when our unit is not in the centre of the farm, but we need to get all the power out to the centre of the farm, and then we can branch it off from there. So so that's what we call lead out, is when we're sending the power out to the middle of the property. Earthing, you know, is all to do with, like I just said, gathering that power up and bringing it back to the earth terminal. And obviously we need the fence. We need a well-constructed fence. Most of you guys have got that fence bit covered. You know, everybody focuses on this, and not too many people focus on this. But today you'll realise why we need to focus just as much attention on this. Okay, so all right, let's just go through some of the terms we need to use just to make sure everybody understands it. Amps. So if you've got the flash fault finder, which I don't have one here, it has amps and volts. So amps is current flow. So it is the flow. Like I'll keep referring back to like water, because it has the same characteristics as water. So it's like litres per minute. So amps is like your flow. Voltage is your pressure. So that is, you know, how much pressure, how much electrical pressure is in the wire, is in the fence. Well, I'll ask another question. So, dead right. So electric fence is like a water pipe that dead ends with the tap turned off at the end. So the power goes to the end of the wire and is held there for the length of the pulse, and it's dead ending. So it's not going anywhere. So we should have low flow, or low amperage, and high voltage, high pressure. We should have lots of pressure in the fence and very little flow. So amps, it depends how big your unit is and how big your fence is. Obviously, everything actually leaks. Like the insulators leak, it actually flies off the wire, everything leaks. So you will have amperage. So even when your fence is really good, you'll have amperage, unless you've only got 100 metres of fence. You know, you could get a perfect fence with 0 amps and high voltage. But if you've got, you know, joint clamps and insulators and that, it all leaks a tiny little bit and it all adds up. So the longer your fence is, the more the amps will add up. And then the bigger the unit, the more the pressure, the more that leaks out of those individual components. So just keep that in mind when you are testing your fence, you know, and what it should have. Stored joules. Now this is what we use to identify how large an energiser is. Everybody uses kilometres, but different manufacturers just put whatever they like on the box, like for kilometres, you know, and there's different reasonings for that. But when you want to compare apples, when you want to come in and replace your old one with a new one, and the old one was adequate, like it was doing a good job, you look at the joules. So you look at the stored joules and you get one that's exactly the same or bigger, whatever you want to do. So stored joules is actually, so what it does is the energiser loads up between the pulses. It loads up electricity in these big capacitors, so like temporary batteries. It loads it up and it lets it go down. So stored joules is the amount of capacity that energiser's got to store the power. Okay, so basically the bigger the energiser, the bigger the capacitors. But as we get bigger, we need to upgrade everything else to handle that amount of power. So that's why the energisers get bigger and bigger, and they're more expensive because we've got to beef up all the other bits and pieces that are in it to handle it. So output joules is, so just like a water tank, when you pump a water tank, you never get 100% of the water out. So there's always a little bit left in the bottom. It's the same with output joules. Your output is never as big as your stored. So some companies quote output joules. At Gallagher, we quote stored joules because we know it's a level playing field. So, and a lot of the units now, like these I-series here, they have adaptive control. So they have a computer in them that monitors the fence, and you can have a stinking big energiser and it will only put out what it needs to put out to keep 8,000 volts in that fence. And within a millisecond, if a branch goes over the fence or something, it will open the tap. It will let the power go to try its best to keep 8,000 volts in the fence. So that's adaptive control. So your output joules varies with the computer. So yeah, so stored joules is your capacity of your energiser. Output joules is what it lets go. So with Gallagher energisers, it's all in the model. So you know how many joules it is. So this M160, M stands for main, so it's a mains unit only. 160 is that it's 1.6 joules. Okay, so you drop a couple of zeros off it usually. So you drop 2 decimal points off it, so that's 1.6 joules. All right, MBS, mains battery solar. So this will take multiple power supplies. How many joules is this one? First one gets the bag of pegs. How many joules? 28. 28, there you go, well done. So 28 joules. So you don't have to work real hard. So what you can usually do is Google your old energiser, and generally you'll be able to work out how many joules that old energiser is, and then just go in and get something. At least you're apples with apples then. Like kilometres, here's a good example of the kilometres. So we're saying 3 kilometres on here. That's ideal conditions. That it would absolutely be running flat out. You'd only be getting 3 or 4 kilovolts out of it at that distance, and you'd have to have it in the middle. So it's pushing 1.5 k's that way and 1.5 k's that way. You put it at the end and ask it to push 3 kilometres, it will kill it. So that's absolutely flat out. On the back, we say we recommend typical Australian conditions. So that's allowing it to run at 8,000 volts, 7 or 8,000 volts. You'll get a lot more performance. If you get a bit of grass and that touching the wire, it'll be able to handle it. You'll be a lot happier with it. And so we're saying only 1 kilometre. So if you put this S30 on 1 kilometre in the middle of it, you will be a lot happier with the performance of the unit. So yeah, so that's what we mean. Typical Australian conditions, light conditions, or ideal conditions. So just be aware of that. Just be aware of that. The reason that we leave that on the front there and don't do typical Australian conditions is because a lot of the other manufacturers put it there, and if we are sitting next to them on the shelf, that would, you know, they'd say, oh, this one, it's the same price but only does half the distance. But just keep in mind that if you want the fence to perform at a nice high voltage, really look at this typical Australian conditions rather than the maximum. All right, ohms is a measure of resistance, so that's the enemy of electricity and electric fences. The less wires or the smaller the wire and the more the distance, the more resistance we have, the more ohms. So, all right, here we go. 8 out of 10 electric fencing problems are due to improper earthing systems. So, you know, we can have rusty or corroded earth stakes and wire and not using clamps, just twitching things on. Broken wires, not enough earth stakes, too close together, and poor connections, as I mentioned. You know, we've really got to look after. You know, we've got to spend as much time on our earthing system as we do on our fence. You know, because it's just not going to work. We're just not going to get that return of the electricity back to the earth if we don't facilitate it. So we have a little jingle, 4, 3, 2, 1. So we want our earth stakes in our earth station. We want them 4 metres apart. A minimum of 4. You can have them longer, but a minimum of 4 metres apart. That's something I see all the time when they're belted in right next to each other. Lots of times less than a metre. What happens then is it becomes one earth stake. If you have them too close, it doesn't give them a field to draw the electricity in from a larger area. So you might as well only have one earth stake. It's not much better than one earth stake having them too close together. So a minimum of 3 earth stakes. So if we've got a permanent system, we want a minimum of 3 earth stakes. So our simple rule is every 5 joules of stored energy. So we're looking at, you know, we're looking at the stored joules again. So every 5 joules of stored energy, we need 1 earth stake. So what I mean by an earth stake is a galvanised steel post, 1.8 into the ground. So that's what we're calling 1 earth stake. So, so up to 15 joules, 3 earth stakes is fine. So, so we want a minimum of 3. So up to 15 joule unit, we only need the 3. Once we get above that, we need every 5 joules after that, we need to add an earth stake. So a couple of examples there. That's our biggest unit that we manufacture, 24 earth stakes. There's other ways of getting around that we'll talk about in a minute. But that's sort of what we're looking at, 6,000 I, 12 earth stakes.
Is the 3 earth stakes to the minimum, is that very close to the energiser, or does that include earth stakes around along the fence somewhere?
So
You've got 24 earth stakes.
Yeah.
per
So
unit.
I would.
Scattered out along the length of the fence line.
So you can. So you can't have too much earthing. So you can't have too many earth stakes. The more the better.
Yep.
So we're talking minimums here.
Yep.
If I had a smaller unit, I would definitely have a minimum of 3
Yep.
at the unit. And then if you could bung some more in some wet areas, some summer wet areas around the farm,
Yep.
that improves things a lot. So it makes a big difference. We're going to talk about earth returns in a minute, but so we'll get into that. But yeah, so when you're talking 24. You can have super earth kits in, which we'll go into. Which are equivalent to 3 earth stakes. So each one of those is equivalent to 3 earth stakes. Or we can have an earth station on one of those big units at the unit, and then we can bung some in around the farm as well to get to that 24. It's as you can see, 24 around the energiser would be a large amount, and hard to put in there. Yeah. So preferably as close to the energiser you could get. So you at least put a decent earth station at the unit at the minimum. 10 metres away from any 240 volt AC earthing. You know how they earth the shed or they sometimes earth the power poles if there's a transformer on it. We want them 10 metres away from there. We don't want them interfering with each other. All right. Now, this is ideally in Western Australia. This is at 90% of areas we should be running a return earth system or working towards it. I always tell when I do my farm calls. I always say, look, whenever you replace a fence, let's change the way we've wired it up and get towards working towards a return earth system. So this is a conventional system that we looked at where we're using the ground to return the power back to the unit. If we've got offsets and we've got ring lock, or prefabricated fencing and offsets or a hot wire on the top, that's perfect. We can use the ring lock to run. We can just wire the ring lock up to return the power back through the ring lock. So basically all we're doing is running 2 undergate cables under your fences instead of one, and one's driving the power out and the other one's hooked to the ring lock, and it's allowing it to come back. And obviously when you get back to the earth stakes at the unit, you attach the ring lock to the earth stakes. So if we've got plain wire fencing, we just need to wire up these non-hot wires. So we'll call them, I just used to calling them earth returns. So anything that I don't push power through is an earth return, and you just use a bit of undergate cable and some clamps, and you just join them up, just the same as you do with the hot wires. You join them up, and then we just run them underneath the gates and back to the unit. So what that's doing is it's just giving the energiser the opportunity to give that animal 100% of what it's got to give. Like it just runs back. It just gives the animal gets the full toll when they touch both wires. So it just works much more efficiently. We don't have to worry about drying soil and stuff like that. We still have our earth stakes because we still need to gather. We still need to gather any power out of the ground. It's just like water. In the winter time, it may choose to use the earth stakes in the ground as well as, some will run through the ground, some will run through the wire. So, it's exactly the same as water. It takes the path of least resistance. So you still have your earth stakes, but you wire your fences up so they're earth return. And it's really, at the end of the day, it's not a huge thing. You're not really changing much. It's just you're just wiring it up. So you're just wiring it up in that fashion. You're not having to put anything extra onto your fence. It's just apart from some extra undergate cable, really. And obviously at strainer posts, if you've got wooden strainer posts, you might want to connect it round the post. You know, you can just even use 2 clamps and a bit of plain wire, because you don't need to insulate earth wires. So, you know, I'm not expecting you to dig up all your undergates. So if you're having trouble, your next best option is to drive some steel posts, drive some earth stakes in to preferably some wet areas, or even just driving them in. Like we've got to get down to some moisture if we can. So what that's doing. Oh, sorry, I'll answer your question. So we're just connecting it to those wires. So and earthing those green wires that aren't hot. So we're just allowing electricity to go 1.8 metres into the ground to try and find a bit of moisture, and then it'll travel through that moisture deeper in the ground to the stakes back at your unit, which are all also 1.8 in the ground. We're just driving the power down deeper into the ground to find some moisture to get back to the unit. So
if you've got star pickets in your fence line, are they going to be doing the same job?
They're not deep enough.
Right.
In the summertime, they're not deep enough.
Yeah.
So they're only 600 mil in the ground. Your soil profile depends where you live.
Yeah.
So I live in Denmark. They get away with murder down there. Like, they have half-baked bloody earth systems down there, and it works because it's always moist. The moisture is always there. We got caught, was it 2 years ago, with that really dry, had dry summer, then didn't rain until the end of May, nearly June. I was getting phone calls in Denmark left, right and centre because they just weren't used to it, and the soil dried out, and they had shitty earths, and they just weren't, electric fences just weren't, and the cattle were hungry as well, so they were putting pressure on the fences, and yeah, it was, yeah. So,
can you remind me how deep it needs to go then, and how the star picket is adequate?
So, well, it says 2. So I actually didn't finish that jingle, did I? Let's go back. All right, so we need it, so 4 metres apart, a minimum of 3, 2 metres in the ground, we're saying, 2 metres in the ground. So 1.8 steel post is adequate. 2 metres just fits the jingle, but you'd no need to buy 2.1s and try and get them in the ground the whole way. Like, and then the one is, we like to have one piece of wire running from the last earth stake all the way. We don't want to cut and join it, because joins make issues. Like, if there's a problem with an earth, it's generally where there's a join. Okay, so it's really good just to have one, like one wire. You don't need to use undergate cable, but I generally use undergate cable because it lasts forever. It's insulated from the weather, from everything. If I've got a large unit that's 10 or 15 joules or bigger, you can use high conductive, which we'll talk about. It's 4 times as conductive as normal black undergate cable. So normal black, high conductive. So yeah, so that's why I like to use, because it's generally not a huge cost, and I just run insulated stuff, and then it's there for the life of the fence and the unit. So it just doesn't. Whereas if you use just normal fencing wire, it tends to degrade over time. So gets a bit of rust in it, creates an issue.
What would be the best way to connect that? Can you run it through the top eye and just piece of the underground out, wrap it, and then onto your next
So
earth wire, or is it?
you can, in some cases, if you're not using JOs, like that product with the oval holes, you can munt these a bit and sort of get them through the top hole. You've got to flatten them out a bit. There's these claws are too, so you'll have to flatten it out a bit, and you can do that. This one doesn't really fit through. So this is the round one that we sell. It doesn't really fit through. The steel post is too big. This is the ideal. So this is our earthing clamp. So if we turn that over, we can use it for round pipe. If we decide to use Gallagher round pipe, we can do that. Otherwise, you turn it over like that, like it's spooning, and then that piece there fits in the Y of the steel post, and we get a nice big contact. So what you do is you strip some of your undergate cable, like give it a good strip, and then you put it under the first bolt and then over the second bolt, and it'll sit there then. You don't have to worry about trying to keep it lined up, and then you just tighten your bolts, and it'll push in the whole length of the steel post. It'll push into that Y in the steel post and crunch right up, and you'll get a really, really good contact. So that's what we recommend. That's what we recommend, and they're for sale here on the shelf. So they've got them in stock, and they're heavily galvanised. They won't rust.
What about gutter bolt?
Well, the trouble with a gutter bolt is it'll probably rust. So rust creates huge issues. So electricity runs around the outside of the wire. It doesn't run through it. And whenever you get corrosion, it just creates resistance. So this is why, I'll cover it while we're here, this is why we're talking about it. This is why we use joint clamps. Because if we twitch our wire onto our fences, if we twitch our undergate cable onto our fences, it creates, you can't get it tight enough. There's little gaps. Even if you use a spanner, use a little twister, you can't get it tight enough, and in the summer and the winter and the summer and the winter it's expanding and contracting, and then it just loosens that twitch, and then all of a sudden you can hear it going tick, tick, tick. It's jumping, and then it's burning the galvanising off. It's burning everything. It's just tick, tick, tick. It's like a little tiny arc welder over and over and over again, and then it burns the galvanising off eventually, and then it starts rusting. So then you've got a dicky joint. So your joint is creating a lot of resistance. So no, when you think about it, no, you think about cars when people, and they're only dealing with 12 volts in a car. You think cars, you think 240 volts with electricity. Every other sort of electrical wiring uses some sort of joiner. So electric fencing is no different. You need to use joiners to get a nice firm connection that will not arc. It needs that really firm connection to deliver all the power to the wire. Okay. So when we're talking these 12,000 eyes, these big units, quite a few of them over on the, we sell the odd few around here, but on the south coast where the farms get bigger quickly, as you get out from Albany, we sell a lot of those, and we just got to we have to beef everything up. We use a lot of this, we use a lot of this high conductive, we use lots of super earth kits, and the bigger the unit, the more effort we've got to put in, otherwise it's a waste of time.
Quick question, how come in the middle of summer when everything is dry and you've got rubber boots on and you touch one wire and you get a hell of a belt, and yet you're not touching two wires, you know, if you've got an earth return,
Well,
touching one.
oh,
Surely the way you're saying now, you shouldn't be able to get a boot because it's not going back to the unit.
it's the quality. It'd be the conductivity of your boots.
You have a rubber sole, tape.
Yeah, so it would be that obviously you're earthing out. So I went to a farm call during COVID of a farmer with an S400 that was grabbing it with his rubber boots on and not getting a shock, and telling me he didn't own a fence tester. He was saying the unit wasn't working. So anyway, I went there. I drove there a couple of hours. I drove there. I needed to get out of the house. It was COVID. We were all locked away, and I met him out in the paddock, and we distanced and that, and I touched it with my fence tester, and it was going full choke, and I could hear it going really well, and he still wouldn't have it. He wanted a replacement, so I challenged him to take his boots off and touch the fence, and he did. Oh. So those boots were insulating. Yeah, so all I can say is obviously you were, you know, it's a physics thing, so obviously you were earthing out somewhere. Yeah, so maybe it's the... so that, to give you an example, that black trickle pipe that people bang through the top of the steel posts to use instead of an insulator, that has a lot of carbon in it, and it leaks a lot more than an insulator. So it's what the plastic's made out of. It's made to cart water around. It's not made to insulate. And so as a general rule, those bits of tube, and they just leak a bit more. So it's there's a little bit more amperage, and you need a little bit more a bigger unit when you're using that. So maybe your rubber boots, whatever they were made out of, they had a lot of carbon in them, and so they're conducting. So it just depends what the manufacturer's made the boots out of. Because if it's insulating, you're not getting a shock.
So theoretically, you could work on an electric fence if you've got the right boots on.
I'm not gonna. So, who gets electric shocks from their gates when in the summertime when they're opening the gates? Yeah. So that is insufficient earth. So what's happening there? The ground's got too dry. It can't get back through the soil, so it's hanging in the fence and the gates. So and it builds up. So it'll build up. Quite often you'll get a shock, and then you'll go back and you'll release it out of the fence to the ground. You release it out of the gate, and you'll go back, and it won't get you again. You can open the gate, and that's because it's built up. It's not getting back to here, and so it's building up in here. It's not getting back to here. It's building up in the gate, and if it's ring lock, it's building up in the ring lock, and you're just giving it a path to, and it's built up, and there's quite a bit of pressure there, and then bang, it goes down and through your feet into the ground.
Could you solve that easily by putting a stake?
Correct.
At that gate and pressing it out?
Yep. So, the simplest fix is if the gate's there and I'm standing on the side where the energiser is, it's coming from the other way. So it's returning to the energiser. So you would put it on the far side of the post. So just drive something down into there and then connect it to the wire. You don't need to connect it to the gate. You need to drain it all out of the wire that's there. The best spot is wet areas, like I said. The best spot is, you probably don't need to do that. That's a last resort. If you fix your earth up, you won't need to put those ones in there. So if you drop them in those wet areas or make a return earth system, you won't have that issue. Because what's happening is the power's coming down to the gate and going under and carrying on, and it's not building up in the gate if you've got that return earth system in, and it's going directly down, and it's not building up pressure either, like it's not all being built up there. It's allowing just free flowing back to the unit. So,
Wet area question.
yeah.
If you're in steep country and you don't necessarily have like summer pasture wetness,
Yeah.
is putting in a flowing creek a no-no?
No. We had a customer. We'd done a heap of, in March. We'd done a lot of farm calls here in this area. We had done 8, and the whole 8 were all insufficient earth. It was all the same problem, and we had one farmer put it in the dam right next to the water, and it solved his problem. It was in the pump house next to the dam, so he just put earth stakes down near the water, and they're actually under the water in the winter time. So yeah, no, not an issue. Not an issue. So look, I should have covered this. So this is a super earth kit. So if you've got dry soil, really having like trouble with your earth system, these are a really good product. So they're about $150 each. So it has a 1.2 metre stainless steel rod in there, and it's filled with bentonite clay and salt. Okay, and you can water this like your fruit trees. So you can just go along once or twice in the summer with a watering can and just wet the bentonite clay up. And in really bad soils, we see the voltage and the amperage lift on the unit like within 5 minutes of watering it. So, so how this works is you rip the top off this. I use, those black soft buckets you buy from Bunnings. I use one of those, and I pull this thing out and tip the contents into the bucket, and then I rip the bottom out of this. And if you've, like a lot of the places where we use these, the soil's quite hard, there's a lot of rock, so they'll use a post hole digger to dig the hole down into the soil to get it down far enough. And then you take the bottom out of this and you just stick this cylinder in the hole, because we only want a 100 mil hole, which this is the diameter of this. So we backfill it, we tamp it down, and then we mix some water with the bentonite clay and the salt in the bucket, and we just get it, I used to say, to a cement consistency, but I find now I've done quite a few of them, I get it a bit wetter than that. You've got to have it so it pours, otherwise you can't get it into the hole. So it'll dry out, like it'll set. So then you just pour it in, and then I bang this, and then you can leave this in, but I pull it out. So I like to pull it out, and it drops the bentonite clay and the salt down, sort of that far. And so then you just fill that with a coarse aggregate like blue metal or stone, nothing with soil in it, and that's your little watering pot. So you fill that aggregate up with water, and then it just filters down through the bentonite clay and the salt. And that's worth 3 steel posts. So for every one of these, you can take away 3 steel posts. Okay, it's because of the bentonite clay and the salt and the surface area. We got 3 times the surface area there. So and we're able to water it really well. You can water steel posts if you're having trouble. Like I've got guys that have got them near irrigation systems and that, or where the stock trough is, and they have like a little trickle system. And they turn it on every now and then, and it just drips and wets the soil around the steel posts. But that is a really good product. If you're having trouble, or you just want to get a really good earth system in, or you simply don't want earth stakes everywhere, you can go with these, and then you cut a third of them back. So back to a third. So it's a really good product. 4 metres. Well, it can be 10. It should be 4. You know, we've got our hot wires joined together, running from the unit, and then with an earth return system, we've just joined up these two non-hot wires or earth return wires, and we've put them in. And you would do the same with ring lock. You would just, you know, with prefabricated fencing, you would just clamp it to the ring lock and put it down to the earth stake. So, all right, lead out. So this is all to do with resistance and getting the best out of your unit. So quite often we don't have our energiser in the middle of the farm because we've got, you know, maybe the sheds in the house are up near the road. It's very much the case on the old dairy properties and that around this region. House, because it gets so wet, the house and the sheds have all been put up near the road and the farm goes back. So what we need to do, and the power supply is here, so what we need to do is get the power up to the middle of the farm. So we need to, you know, once you get over 10 joules in energiser, we start to see benefit from using either high conductive undergate cable. So it's aluminium coated, this product, and it's 4 times as conductive as that. So it's like having 4 of these joined together in parallel, but you're just running one wire. So we do that in non-insulated as well as a 1,000-metre roll for people like. We use it a lot in exclusion fencing, keeping wildlife out. We keep the maximum power all for 20 k's all the way to the end. So using this on at least this red section. So once we get to here, we're running it out to shorter runs. So this is ideally how we should be setting a fence up, setting your farm up. Like lots of short runs off your main lead out. So, you know, we've got undergate cable there and it stops here at this strainer and it runs up here and then stops there. So just lots of short runs. If you can imagine a star, we send it to the middle and we send the fences, we send all the wire out in different directions. So that limits the distance that it has to travel. Quite often I see the energiser comes out, we use the boundary fence as the lead out, and it comes all the way back here. Now that just puts twice as much pressure, twice as much resistance on that energiser. It's struggling. Like, you know, you have to buy a lot bigger energiser. You're not getting as much voltage. Yeah. So if we can, you know, if we can run it out the middle and make sure. So as well as using high conductive wire, you can run multiple plain wires. So if you've got three wires, hot wires in your fence, and then you just join them in parallel from here to here, that is a great lead out. So, you know, instead of 2.5 mil diameter of wire, you've got 7.5 mil when you join them together. Important to join them at both ends. So join them together here and join them together here. So all the power can join back together and go out in all these different directions. Okay, any questions about that?
If I can be rude, in terms of lead out, when I established my electric fencing down here on Cowaramup Road, it would have been in the late 80s, so
yeah.
30 odd years ago now. That underground cable like the black one you've got there, to my knowledge, wasn't on the market.
Yep.
And so I, as a lead out for about 100 feet, I suppose, 30 metres thereabouts, I used what was sold as the undergate cable, which is a very small wire.
1.6.
1.6, that's right, thanks to
Yeah.
And I just wonder sometimes when I'm a bit short on power, whether that in itself may be a limitation.
Correct. It is, very much so. It's causing a choking point in your fence.
Yeah.
Yeah, 1.6 was easy to use, but we're talking surface area, and it doesn't have a very big one. So even this is a choke point on a energiser that's bigger than 10 joules. But obviously, the bigger the energiser, the more of a choke point it is, the more of the amperage current flow you've got.
Yeah.
So yeah, it can be a choke point, and that's why we have that product. So, but yeah, poor old 1.6. Yeah, saw a lot of that. Replaced a lot of that on the property I was managing. A lot of 1.6.
I'd like to replace mine too, but it's dug down into the ground and gravelly stuff, and it's more than a hand job to dig it up.
Yeah. So, all right. So that's what we're talking about there. We're talking about resistance and wire. If we've just got a single 2.5 fencing wire and we've got a small unit on it, we're not getting, there's no voltage at the end. We're not getting much voltage at the end at all. So we replaced that small one with a nice big one. And so we get more voltage here, and we do get more, but it is lower than here. So, so a big unit just doesn't fix. When you've got it wired wrong, a big unit helps, but it doesn't fix the issue. So by having 3 wires, all joined together in parallel, or on lead outs, sometimes I get farmers, when they're using offsets, we'll go with something like our live tick product, and we'll put 3 wires in the one offset. So we'll just run 3 plain wires in the one offset, just a distance to get it to where we need to get it to, and then we're just back to single wires. That's guys with all single wire all over their farm. Yeah, so that's another option. But yeah, so as you can see there, big energiser, we got high voltage right at the end. So if you've done it well, your volt, and you've got a big enough energiser, if you've got a nice big energiser and you've done it well, you'll have higher volts there than you have at the unit. So if you've done it well, like at home, I'm probably 1.5 kilovolts better off at the end of my fences, like right at the end, than I am at the unit. So I set my place, so I do field days, I do days like this, but on farm days down there in Denmark every now and then, so I've set it up, best case scenario, with return earths and earth stakes and that, and I've put a couple of these in to show people, and yeah, I'm definitely about 1.5 kilovolts better off at the end. So
seems strange. How do you explain that, getting more power at the other end?
So the dead end. Yep. So what? How like if you've got a pier at the beach, and the wave comes in and hits the wall, and then it runs back out to the ocean. It's the same thing with the electricity. It hits the end, so you're fairly sending it down the wire. It hits the end, and then it builds back. And the bigger your unit, the more it builds back towards the unit. So that higher voltage will run back further and further depending on the size of the unit as compared to the length of fence you've got. So yeah, so it builds back up the fence. Yeah. Yeah. Well, it dissipates between the pulses. So it does dissipate, but yeah, it rams it down, it hits the end, and then it comes back. Yeah, so that's why you get higher voltage. It's because it's a dead end.
With the lead-out cables, you used to be able to get 2 cables like together, a red and a green one. So when you dig a hole, you know which bloody one was going to be earth and which one was going to be live.
Yeah.
You don't make them anymore?
No, we weren't selling enough of it, and I actually got a couple of rolls at home still, but you can have it, but I don't use it. I use this stuff. So we don't make it in high conductive. That was one of the reasons. So it was great if you're under 10 joules units. So it's good, but you're starting to get restrictions if you're using it on bigger units. That's all. Yeah. So they discontinued it. The sales weren't big enough for it. So just a couple of products. So we've changed our solars to lithium. People say, "Oh, what's the big deal about that?" It's completely changed the landscape of these integrated solars. So what I mean by integrated solar, it's got the battery, the solar panel and the energiser all within the one unit. It's our portable fencing units. So the lithium battery charges 3 times as fast, or 300%. It's good marketing. So 300%. In the old one, 80% with an old lead acid battery, 80% of the battery was still charged when it was flat. So we're only really dealing with 20% of the capacity of the battery. So we had to have fairly big batteries, and they're heavy and they're full of liquid. So with a lithium, we're able to drag a lot more. Like we can drain that battery right down within an inch of its life. So we don't have to have because it charges 3 times as fast, and we don't need as big a battery. These are 50% lighter now, and lead acids give off a gas, so we couldn't really seal them up. We had to let the gases get out, otherwise you end up with a little bomb. So, but with the lithium batteries, it doesn't emit that gas. So we've completely sealed the units up now. We've sealed them shut so the ants and the moisture can't get in. So so that's been really good. Yeah, and they're just they're cracking little units, and so we've replaced them in our smaller range. We still our 1 joule, 2 joule, and 4 joule are still lead acid at this stage, but all our smaller portable range have all been changed over to these lithiums. So yeah, they're a really good little unit. It's been a bit of a game changer because the ants used to be an issue with the other ones. So so we have there's various. So we have various sort of fencing systems. So this is our I-post system. So it has like an I-beam and the holes are through the middle. So this is our fencing system for plain wire fencing. So we use it for multiple things, but the main thing is so this clips onto the steel post. So it's our insulator as well. So so it also gives us our rigidness, and it's our insulator as well. Where are we? So we have special spring steel clips, and you only use 2 of them, one at the top, one at the bottom. Will not move. The spring steel is harder than the high tensile wire. If you choose to use something like Tie-Easy high tensile wire, and when you wrap it on, it actually bends the wire. And so I used to do demos where I get a sledgehammer and I'd hit these and try and slide them down the. So it grips on, and then it just holds on like that around the wire, one at the top, one at the bottom. Super tough. I had a fire go through in 2022, wipe all my fencing out, all my boundary fencing out, and I've gone to this and absolutely love it. Nothing. So I get 3. I've gone 7 wires. You can have whatever you like. I've gone 7 wires, 3 hots in the 7. And my sheep dogs won't even go through. Nothing goes through. The kangaroos. So it's very, very rigid and flexible. Easy to repair if a tree falls over it or something, being plain wires. and nothing rubs or scratch, you know, nothing touches it. So, so that is a. Now the idea of this is no shorts. That's the whole idea of it. Is there's nothing. You have to break a wire, or a tree has to fall over it for there to be a short. Like no insulators breaking. We call this an unbreakable insulator. So you can.
The only disadvantage, you have to run the wire through it for a length. You just can you tie it? Have you got clips that you can?
No. The idea is you tie it through, so it's to stop that. If you clip it on, you're just creating another way that it can short out. So by running it through, we have a system. We lay them all on the ground, and we have a needle. And we actually, when we're running the wires, we thread them through, and we strain them and tie them off, and then you just run these down. You run these down the fence, or once the fence is... The first thing you do is you put the steels in, then you run your wires, threading them through. If it's a long fence, you can have some up each end, so you thread them each end, and you just run them through, strain them up, and then the last thing you do is spread them out and clip them on. The biggest thing is you've got to get your maths right.
Maths, right.
Yeah, because you've got to have the right amount of posts. I tend to put an extra one in, because you can always hide an extra one. Like we use them on the... I also put extras in for the strainers, so we just use it to insulate the wire off the strainer, you know, so that it can lean on here. Like if you're using a metal strut or something, it just protects it from shorting out. Yeah. So we also have something like this for retrofitting to stop animals, wildlife from going under an existing fence. So we just put that through there, and we clip it onto the ring lock, and we run 3 wires through there. We call it a three-dimensional fence, and you can have 2 hot wires and an earth return in there, and nothing will go under. So they've got to climb through that, and we also use the existing ring lock for return as well. So if they start climbing through it, they're in the summertime, they're getting a really big whack. So that is a good way, and it even works on the inside. If you've got a neighbour, and obviously he doesn't want it on his side, you can actually put it this way, and so they'll go through the ring lock, and then they'll hit the hot wires, and if you've got the ring lock as a return earth, he's leaning on the ring lock, he touches the hot wire, bang. So he's backing out pretty quickly. It's another variation. So what we're trying to do here, this is a flexible post, it's an insulated line post. It won't rust, it has a 16mm fiberglass pole in the middle of it. You clip these on, that's how you clip your wire on. Anywhere here we have a horse tape post, horse tape clip if you want it for 40mm horse tape. And that is, so I use that around my trees when I'm planting trees. It's used a lot in just for quick subdivisional fences. It's a replacement for a steel post, and the idea is even if one of these clips come off, the fence is not going to short out because it's insulated. This is a fiberglass and nylon coating on it, and it's not going to short out. So again, it's not chasing shorts and not having your fence go down. That's what we're trying to create some products that give you less maintenance. You know. So this is our I series energizers. We have 5 models. They're our flagship energizers. So I spoke a little bit about these before. They're got adaptive control. You can buy a Wi-Fi gateway, and then you can download our free app, and then you can turn your fence on and off. You can monitor it. It sends you alerts. You can set your voltage and your amperage for thresholds, and it will send you a message if the voltage or the amperage reaches that certain point. We have alarms. We have monitors, which monitor is basically a permanent electric fence tester wired into your fence, and then it just talks back to the unit and the controller between pulses, and then if you got this, it'll send it to your phone, and it tells you what the voltage and the amperage is at all times in these particular points on your farm, on your property. So we have a fault finder remote that is only for these units, these I-Series units. So it's your fault finder, but it also turns the fence on and off. Your app can also, you can switch your fence on and off on the app. And we have an alarm. We have various products that go with this energiser. We sell them all separately, so you don't have to have that. You can just buy the energiser and put it on, and away you go. But if any of this suits you, you can purchase any of the add-ons. So there's quite a few of them, but it just adds to this latest, absentee owners and people with multiple blocks. They want to know how their fence is travelling. I think Matt's got a super deal for you on this one. Yep. So if you're interested in that, I think Matt's got a super deal for you. If lightning diverters. So when you put a new unit in, if you install one of these, they simply just go next to your earth stakes near the unit. If you install one of these, when you buy the unit, just keep your receipts and staple them together, or take photos of them and store them away. We guarantee if you put one of our lightning diverters on a new unit, if it gets struck by lightning in the first 3 years, that we will replace it free of charge. Yeah. So we make that guarantee because especially these new units with computers in them, we really need a surge protector on the 240 volt as well, because it can come in from that end. We can get power surges and everything from that end, so we really should be putting something on that end, and then on the fence end we put one of these in. So and all it does, it diverts, and so the lightning just wants to go to the earth stakes, but to get to the earth stakes off the fence, it's got to go through the unit, and it just absolutely fries the unit, melts all the solder, blows the circuit board. It just depends how direct the strike is. But it doesn't need to strike the fence. It can strike a tree next to the fence, and it'll run through the ground and up into the fence, because it's the path of least resistance. So yeah, so just keep that in mind, that if you're purchasing a new unit, grab a lot. It's 5 minutes to 10 minutes to install, and then you just adjust it. You put your screwdriver in, wind it down until it starts shorting out, and then you just wind it back until it stops, and it creates a little gap. But the lightning will prefer to jump that gap and go straight to the earth stakes and through the unit. So that is a really good product to keep the strain on it.
Yeah, like
So you're using the reel to strain it?
The reel,
Yeah.
but it's still somehow, you'd come back a couple of days later and some of them would have popped out and all of that.
So do you turn them side on? So you put them in, and then you turn it, and then you stamp it in. Is that you don't have it that way, do
Put
you?
them all out first and then just run it.
Okay.
Yeah.
So you do it that way.
Yeah.
So what you got to do is they're designed to slot in there, and then you turn it, and then you tread it in, and then that way it locks it in here. So yeah, you got a gap. So you have it parallel to the braid. You drop it in, and then you turn it. You turn it so now the wire's now it's coming through here, and for it to come out, it's got to be twisted sideways.
Roll out 4, like, you know, 4, like it's all right if you've got cattle like that, but like if you're trying to get 4 of those, like if you've got lambs and all that,
Yeah.
how do you do all of that?
So you just lay it like that and you drop them in, pull it up, twist it, drop it down. So, or you can, if it's loose enough, you can go that way. So have you got the animals touching the fence, have you?
Yeah, you know, like if you've got lambs and, you know, like sheep, they just knock their heads up, or little lambs will go through, and
Have you got enough voltage in your fence?
I would think so. It's identical to what you got there, that solar one.
Yeah.
And
Do you have a voltmeter? Do you have a...
No, I need to get one. I've got that thing that shows the lights.
Yeah, that's right, you were telling me. Yeah, no, you need to know what you've got. Your unit may not be big enough. If you haven't got enough voltage, your unit may not be big enough. And you really need at least a voltmeter, if not a fence tester. Like for electric fencing, portable, really a voltmeter is probably adequate, because you can test whether there's any breaks and you can see what voltage you've got in it. So, but you really should have some sort of voltmeter so you can make sure, because they shouldn't be playing with it. Like,
Because I'm from the wheat belt. We just put your ring lock in and bang it in and you're done. So
Yeah.
I've never used electric fencing before. So.
Yeah, no, I think just make sure with the temporary fencing, just make sure you've got plenty of voltage in it. Like I said, there's no physical barrier at all, so you don't want them playing with it at all. They want to be keeping away from it, you know. I use this rip-roaring unit and they don't even graze underneath. They stay sort of 300 off it. So that's if you've got adequate voltage there. Well,
I just asked a question about switches. You got these knife switches.
Yep.
I've been going through them like going out of fashion because they keep shorting out and burning things. And then you've got in your book here a cut-out switch, and it's got a little square and it's got 10. Does that mean it's guaranteed for 10 years?
Yes, but it is. But those cut-out switches are only for 5 joules. They're only for. I take it you've got a bigger unit than that, and it's burning them out. So you need the other switch.
Which is just a cut-out switch.
Yeah.
So
that's fully sealed.
Why sell them if they're not going to bloody work?
Well, they're for smaller users and smaller properties. Yeah.
We're all hobby farmers down here.
Yeah. So if you got more than 5 joule unit, you shouldn't be using that one. Yeah. So you know, a bigger unit will burn them out. Yeah. So just use the other one, and leave the other one has a protector on it, on the terminals there. So just leave that off if the animals can get to it. Leave that off so if they start licking it, they.
Yeah. Don't always leave them off anyway. They're a pain in the arse.
Yeah. Yep. So that's a mistake.
So
People.
Did you say that knife switch should be?
5. Yeah.
Quick question. On the reel, I was installing one a couple of weeks ago with one of my neighbours, and I'd never dealt with one before. He was asking me which end is supposed to be energised, and I didn't know. We hooked the hook end over the wire down to the neutral as a means of energising it, but where it winds onto the reel itself, is that supposed to transfer power through to the hook that you hang on?
So there's that wire there you can use. There's a wire here. There's a wire there you can use. You can clip a little jumper lead onto there.
Oh, yeah.
You can put the portable energiser clip straight onto the braid, like the alligator clip, and preferably if it's a short fence and you've got a reasonable size energiser, you can just clip it on the end, or you can jump it off your main fence. If it's a longer run or you've got a smaller energiser, put it in the middle. Obviously on the other side, so there's only the livestock can't chew on it. So put it on the outside and put it in the middle so it's got shorter distance to run either end. So, yeah, so you can You can clip it straight onto the wire, you can put it on there. You can buy one of these with a metal end on it, and so you can either have it as insulated or you can pull it that way and you can hook it onto an existing hot wire and power it that way.
Cheers, thanks everyone for coming, and thanks Murray for taking the time out of your day to come down and hopefully we'll all learn something. And if you have any other questions or whatever, just let us know if I can try and answer with my limited experience, but Mum's always there on the phone, so
If I didn't get, I've got all about what we talked about today. We have a little manual, a handbook. They didn't get here in time. They were being reprinted and then they had to come from Victoria and they didn't get here. So I will drop a heap of them at the store here, so you'll be able to come in and grab them in the next month, I'd say.
I'll have a couple of you, so if you want me to